Okay. Okay. So let me go ahead with the subject operation planning and control. Right? Okay. So here we have the very first module. Please note down the important topics and how the question is going to be asked. So I'm just giving you the hint. Please don't assume that the same words are going to be asked, right? It the meaning will may be the same, your answer may be the same, but the framing of the word for the question will be little bit different. Okay, take it. So let me start with module number 1. So here we can have explain the production and operation functions, right? That can be the first question. Then second question may be define the production systems and classify it. So in detail, I have given you the differentiation of various production systems. You need to explain it. Okay. Now, the next one is make to stock and make to order. Mention me whether I'm a little bit fast or slow. So accordingly, I'll manage my speed, right? Am I audible?
Yes, ma'am.
Okay, fine. So the very first is the explanation of production functions and operation functions and how it is important in the production floor or in terms of operation planning control, right? Okay. The next one is define and classify the production systems. Right. Now, in terms of a short notes, they may ask for the make to stock and make to order. What is the difference between make to stock and make to order? Or otherwise, in terms of a short note, explain make to stock or make to order. Then the next category or extension of the same is assemble to order and engineer to order. Right? So in either of the combinations, this question may be asked. Maybe it is of 5 marks or otherwise it is of 10 marks. Okay. The next one is explain types of layouts. Now here, as I told you, that the framing of the words for this particular question may vary. Instead of asking in a simple word explain types of layout, they may ask illustrate the types of layouts. Now understand the meaning, right? Illustrations means you need to explain the types of layouts with the help of example, right? Okay. Then next question can be the phases of OPC that I have already explained in the slides, right? Which I have shared with you. Explain the phases of OPC and how important it is in the how important this is in the performance of production. So we have various phases, pre-planning, planning, action and control, right? And under this heading of pre-planning, planning, action and control, again we have a sub-phases. Okay. Next, am I audible?
Yes.
Okay. The next one is in terms of short notes, this can be asked as post choice model or otherwise operation models. Next question. Explain the strategies adopted for the planning of operations and services. So at that time, you need to explain quality, productivity, and technology strategies. Right?
Yes.
Next one is explain services and its type. Explain services and its types. Next, classify the services. Explain the service capacity. Okay, so completely theory portion or theoretical questions are going to be asked from module number 1.
हेलो मैम।
हाँ बोल बेटा।
मैम ये जो प्रोडक्शन एंड ऑपरेशन फंक्शन है और वो फेसेस जो ऑफ ओपीसी है उसके आंसर सेम है कि अलग आएंगे?
The previous one, that is production and operation functions, that are a summary, right? Answers are both answers for both the these questions are same, but production and operation functions are in terms of a summary you need to explain, that is from 1 to 10, right?
ओके
But when it is going to be asked in terms of a phases of OPC, at that time you need to explain under the heading of pre-planning some of the functions. Three functions are there, right? Then under the heading of planning, again three functions are there. And in terms of an actions and control, again four functions are there. So in that way, you need to explain phase-wise. Okay?
ओके मैम ओके।
So this is belonging to module number 1. Now let's talk about module number 2. Now, module number 2 comprises of two parts. The very first is a forecasting, and rarely the theoretical questions has been asked from the this particular topic, forecasting. It's forecasting always been asked in the university in terms of a numerical of 10 marks. Right? Yes, of course. If the short notes are going to be asked, then it can be in terms of the differentiation of forecasting and prediction, right? That I have already explained in this slide. It can be in terms of a short note of need for forecasting, right? Then role of forecasting in OPC. Classify the forecasting techniques or methods. So at that time, you need to explain qualitative and quantitative methods. If you prepare a summary chart, which I have mentioned in the slides, it will be better for you, right? And then after all these methods are in terms of the numericals they are going to ask, right? So majority of the time they have asked the numericals belonging to least square method, exponential smoothing method, and then moving average method. Hardly once, I guess, they have asked numerical belonging to the forecasting error. Right? Okay. Now, in terms of a short note, they can ask forecasting biases. that the opportunity or probability is very less, because the syllabus is so vast that this forecasting biases are having very rare chance to be asked in the short notes. Okay, so let's move ahead with the capacity planning, the second part of module number 2, right? Okay, now this question can be asked in terms of either a short note or in the 10 marks questions. What are the measures and measurements of capacity? Explain factors influencing effective capacity.
मेजरमेंट ऑफ कैपेसिटी.
Pardon?
पहला क्वेश्चन क्या था? व्हाट आर द मेजरमेंट?
हाँ, what are the measures and measurement of capacity? The second one is explain or narrate the factors influencing effective capacity. Right? So here we have a two-part: effective capacity and over capacity and under capacity. So usually we are focusing on effective capacity, but sometimes it happens that some of the factors are, favoring the over capacity. Like take an example of a seasonal product, as I have explained in the class, that at that time over capacity is favorable. And there are some of the factors which are favoring under capacity as well. So it can be asked in terms of factors influencing effective capacity, factors favoring over capacity and under capacity. And then the last one is capacity requirement planning, the short note. Okay. So in the second part of the module number 2, we have capacity planning as well as aggregate planning. So this aggregate planning will also be falling under the theoretical questions. Okay. So question can be in terms of what are the strategies adopted in the organization for aggregate planning. Repeating once again, what are the strategies or types of strategies adopted in the organization for aggregate planning? So at that time we have three basic strategies, that is pure strategy, mixed strategy and level strategy. Most of the time short note has been asked for rough cut capacity planning. In the previous syllabus, aggregate planning for services has not been included, but this time in OPC they have included. So it can be a short note or a question belonging to aggregate planning for services. What are the models? What are the linear rules? Right? And of course, very important topic, that is a short note for master production schedule, MPS. Most of the time in examination, this short note has been asked, or otherwise in terms of a question, partial question.
लॉजिस्टिक में था क्या मैम मास्टर प्रोडक्शन शेड्यूल?
नहीं, PPC में, yeah, it was there. In PPC it was there, but not, I can say in detail. It was a sub part of some other topic.
नहीं मैम, लॉजिस्टिक में था क्या हमारे पिछले सेम में मास्टर प्रोडक्शन शेड्यूल जैसा कुछ?
नहीं नहीं नहीं, in not with respect to the planning purpose.
अच्छा, क्योंकि बहुत सारी चीजें हैं जो लॉजिस्टिक के टॉपिक से मेल खाती है, मतलब ऐसा लगता है कि उसका ही कुछ एक्सटेंशन इस सब्जेक्ट में है।
अच्छा ओके,
मतलब वो हुआ अपना, अभी क्या था वो, पुश पुल सिस्टम का एक्सटेंशन ये वाले क्वेश्चन में लगता है।
अच्छा ओके।
कुछ तो था
एक्चुअली
विंटर सीजन है तो क्लोथिंग
सी
ज्यादा है, वो इनोवेटिव प्रोडक्ट्स और फंक्शनल प्रोडक्ट्स जो है, मतलब लॉजिस्टिक जैसा ही लगता है ये पूरा।
हाँ, actually what happens, these are all interconnected,
हाँ
right? So
हाँ
master production schedule is basically for the production of the product. So now this production has to be stored in inventory, and inventory is linked with the orders received from the customer, right? And depending upon the order, we have to have the logistic planning. So
हाँ।
these are all interconnected with each other.
तो ऐसा बोल सकते हैं क्या कि लॉजिस्टिक कैन बी सब सिस्टम ऑफ ओपीसी?
Yes, of course, because without OPC, you don't have a manufacturing of the product,
हाँ
and unless and until a manufacturing of the product exists, there won't be existence of the logistic. आप सप्लाई क्या करोगे, कुछ प्रोडक्शन रहेगा तो आप सप्लाई करोगे, but effective management of the production and logistic both are depending upon the strategies which we are adopting through the production. And
हाँ
this planning is strategies are having as a part of planning of master production schedule,
हाँ।
right? Okay, now let's go ahead with the module number 3. Now this is completely the numerical part. This mouse is so smooth that suddenly it is going up. Okay. So rarely theoretical question has been asked from this module. Most of the time it is numerical only. Yes, of course, the very, very important short note or otherwise theory been asked from this particular module is the Gantt chart. Right? Okay. And today I wanted to discuss with you this particular third module for the numerical. Okay.
हाँ
So the only theoretical part belonging to this module is the Gantt chart.
सिर्फ एक क्वेश्चन?
Yes, theory, and that is either in terms of a short note, or it can be a part of some other question. It can be asked only for 5 marks, not more than that.
हाँ
Okay. Should I proceed for the fourth module? Today we are going to discuss the numericals belonging to module number 3.
ओके। सिर्फ हाँ, वो तो
Yes.
आपने दिया है कौन सा मॉड्यूल के लिए कौन से टॉपिक के न्यूमेरिकल है।
Yes.
चलिए।
Okay. Now theory, from 100% theory is going to be asked from the module number 4, that is MRP, MRP2 and ERP. Okay. So as I told you, objectives, inputs and output of MRP, it is called as MRP or MRP1, both are same.
हाँ
So these are very important objectives, right? Then inputs, outputs of MRP. Then the whole theory about the manufacturing resource planning, that is MRP2. Okay. Now this MRP and MRP2 may be either a single question 10 marks, or individually it can be asked as a 10 marks question, each of them. The next one is ERP. So evolution, features and purpose of ERP. That can be a question, single question.
Okay.
Explain or otherwise how the ERP has been evolved, and then explain its features and purpose or importance of ERP in the organization. Right? Now, sometimes they can also ask regarding the modules of ERP. So I have given a kind of a graph to you, right? So just by heart that particular graph, and on the basis of that, you can explain it in terms of your own words. Different types of modules of ERP. Okay. Okay. The next question, the next module is module number 5. Now it is also having two parts. The very first is facility layout planning, and the other one is line balancing. Yes. So here in facility layout planning is completely theoretical. Completely. The very common question asked is factors influencing plant layout, what kind of material flow patterns exist, what are the tools and techniques used in the plant layout planning. So these are very common questions. Now, belonging to the line balancing, only the only the numericals can be asked. Right? And the methods which mentioned over here in the syllabus, that I am planning to take it in the next lecture, because little bit more time is required for this explaining this methods. Okay. Now,
ये पांचवे मॉड्यूल वाले न्यूमेरिकल,
pardon?
ये लाइन बैलेंसिंग वाले इजी है या कैसा है?
It's very easy, very easy. Once you understand the concept, now definitely you are going to score 10 on 10. Its diagram itself is going to make you score, 10 on 10. Very damn easy. Just you need to understand the concept.
Yes,
Little bit variations are there in this Kilbridge-Wester largest candidate rule and position method. That is, this difference exists in the beginning only. Then rest of the steps are same. Okay. Okay. Only the first step differs for these three methods. From second step onwards, all the methods are same. Okay, ठीक है. Next one is the
थियरी में क्या पूछेंगे? फैसिलिटी लेआउट प्लानिंग का एक ही क्वेश्चन आ सकता है क्या?
it can be factors influencing plant layout, material. The second topic may be the material. What are the types of material flow patterns? Why this material flow pattern important? Because on the basis of these flow pattern, the types of facility layout are existing, right? So it can be asked in terms of this way, that classify the facility layouts. So at that time you need to mention or explain the same thing, that is material flow pattern. And some of the tools and techniques are used for the plant layout, that also I have mentioned in the slides. Take it. Okay. Now let's jump to the module number 6, completely theory and short note, or otherwise two short notes are going to be merged in the one question of 10 marks. The very first is JIT, just in time, the one topic. Next is lean manufacturing. Then third one is agile manufacturing. And the last one is the synchronous manufacturing. And now, this can be in terms of a short note of 5 marks or the single question 10 marks. So for JIT, you need to explain concept, characteristics, component, implementation, right? For lean manufacturing also, you need to explain the concept, characteristic, component, and implementation, and the same for the agile manufacturing. For synchronous manufacturing, very little material is available. So probability of, asking the synchronous manufacturing is very, very less. So better you focus on JIT, lean and agile manufacturing. Prepare a kind of a note. I have also given in the PT the this concept of JIT characteristics. I have explained under the heading of JIT. Then I have explained concept, characteristics, components, and implementation. So the whole note is very important. Am I clear?
Yes, ma'am.
Huh? So just prepare every this manufacturing system with respect to this 4 part: concept, characteristics, components, and implementation. Okay. Okay. Now, is there any doubt with respect to the theory part and numerical part? So in previous online lecture, I have explained the forecasting methods. Ayush, are you there?
Yes, ma'am.
Okay. Should we go ahead then?
Yes, ma'am.
Okay. Should I go for the this module number 3, which we have left last time?
Yes, ma'am.
Okay. ठीक है. Okay. Is my slide visible to you?
Yes, ma'am.
I don't find the boundary line of. Is it a screen sharing? Are you able to see the slides?
Yes, ma'am.
Okay. Oh, let me go ahead directly to the numericals. Last time I have explained the
सिलेबस कॉपी दिख रही है मैम.
स्लाइड नहीं दिख रहा है क्या? ओके, ठीक है, ठीक है. Let me just go ahead once again with that. Again, I am going to share it. Huh? Okay. Are you able to see the whole screen?
Yes, ma'am.
Yes, ma'am.
Now is it visible? Slides are visible?
Yes, ma'am.
Yes, yes.
Module number 3, job shop intermittent manufacturing scheduling and project scheduling. Is it visible?
Yes, ma'am.
Yes, ma'am.
And I'll go to the numerical then. Let me jump directly to the very important numerical, which usually been asked in the examinations. So directly jumping to the project scheduling. And later on, if time permits, I'll explain you the Johnson's algorithm. ठीक है? Okay. Yes. So I guess you all know about the network diagram that previously we did. Say yes or no?
Yes, ma'am.
Okay. So we know the forward pass and backward pass, right?
Yes, ma'am.
So very simple example I'm starting with. How many of you are, I don't know, though I have explained in the class, how many of you are not able to draw the network diagram? 2, 3, 4, how many? Okay, fine. So okay. Okay. So from the basic I'm starting, but I won't consume much more time in the network diagram. Okay. So just giving you a basic concept of how to draw the network diagram. I'm keeping it in the slide mode. Okay. So here we have, are you able to see the full screen of network diagram?
Yes, ma'am.
Okay, fine. So I'm just giving you an example of a small example how to draw the network diagram. Where there are two types to draw the network diagram, that is activity on node and activity on arrow. So here I have mentioned or drawn the activity on node. So we have activity A, B, C, D, E, F, G. We have a predecessors accordingly, and we have the durations as well, right? So let's start with the method of AON. It depends upon your convenience. If you wish to go ahead with the activity on node, no problem. The result or the outcome or the answer will be same, right? Whatever method you are going to adopt. So let's start. So we have this activity. So we are see, whenever we are taking activity on node, then we have two nodes, that is this first one and the last one. The first one, the first node is called as the start, and the last node is called as the end. So let's start one by one. The activity we are going to choose. So we are starting our whole project. The very first activity we have adopted is A, and it is having duration 2 hours, 2 days, whatever the unit may be, right? So here we have mentioned start, and then we have an arrow. Now there are some rules for the construction of the network diagram. The very first is you should have the nodes in this way only. Then whatever two nodes are given, it has to be connected well with the arrow. There should not be a backward arrow. There should always be a forward arrow. So whenever you are starting the network diagram, let it be from the left to right, not right to left. It is a rule, right? And these two nodes are to be connected, with each other through the end of the arrow and the start of the arrow, right? And it should always be in terms of a forward. Okay, so here we have a start, then we have the activity A. Now whenever we are having activity on nodes, then at that time either inside or outside the circle, that is at the top of the circle, we are mentioning the duration. So here I have mentioned the duration in the node itself or the circle itself. So we have from start to A, then see how we are going to proceed for or assume that this is not this A, B, and C are having a start event over here. So whenever we don't have any predecessors, at that time we need to consider these as a start activity. So here we are having starting point. Now, in details, I have already explained what is start and what is end of the activity, what are the nodes and everything. So directly I'm focusing on the construction of the network diagram. So this is the start, then we don't have any predecessor over here for A. So we are considering it as a starting event. So A is consuming 2 days or 2 units of time. Then we don't have a predecessor for B. So we are also connecting it with the start event. Then C also we don't have any predecessors, so that is why we have considered it as a start. So here we are proceeding with A, B, C as a starting connected with the start node. Now here you can see D is having predecessor A. It means that unless and until A is going to be completed, you cannot proceed further for the D activity. So after completion of A, I have projected it, the arrow has been projected for the D. Similarly, for C, for E, we are having the predecessor as C. So extension of C is going to be your E. Then after we have F. as the extension of the A. Unless and until A is going to be completed, you cannot proceed for the F. So we have two succeeding activity, that is F and D over here, and all are going to be merging for the this G, right? So we are having G activity, predecessor of D, successor of D, B, and E. And ultimately, these are going to be connected with the AND arrow. See, for F, it is not mentioned somewhere. So it means that we need to consider that F and G are going to be the AND, connected with the AND event. Am I clear with this?
Yes, ma'am.
Yes? Okay. So now we have, that was the forward pass. And there are some rules and regulations for the forward pass, as let me explain in this way. In the forward pass, we are going from the left to right, and preparing the network diagram, and as well as we are considering the early start and early finish, right? And in the backward pass, we are moving from the right to left, and we are considering these as the latest start and latest finish times. That I'll explain when we are going to take in a kind of a numerical over here. So here, first of all, we have prepared the network diagram, right? Now we are considering the forward pass. So how we are going to do this? Let me explain in this way. Okay. So here, this is the start. So we have proceeded further over here, and we had a end activity. So in this way, we are going to conclude the whole diagram, right? Okay. Now, in the forward pass, when we are constructing this network diagram, first of all, the very first step is to construct the network diagram, right? Now, for the forward pass, now we are going to mention the time. So each and every activity are going to have a start time and the end time. So the very first cell, red color cell, is going to show the early start and early start time, and the next cell is mentioning the latest finish, earliest finish time. So in forward pass we are getting the earliest time, and in backward pass we are getting the latest time. So let's one by one we'll consider, so accordingly you'll be knowing this. So in the start activity we are having two cell. The early start time is 0 and the early finish time is 0. Why? Because it is a start activity. So that is why this both are going to be coincide with each other. Now let's talk about the next one. Okay. So now consider over here, whatever is the last time or earliest finish time of the previous activity is going to be considered for the earliest start time for the next activity. Okay. So here for A, we are having the earliest start time as 0, and activity A is consuming 2 units of time. So its earliest finish is the 2 unit over here, right? Similarly, for B, we are having the start time as 0 and earliest finish time as 6, because activity B is consuming 6 units of day. Similarly, for C, we are having earliest start time as 0 and the earliest finish time is going to be the 4, because C is consuming the 4 units of time. Now, the picture is going to be very clear for you for the next activity. Okay, now let's talk about D. After C, we are having D. So as I told you, the previous activity, earliest finish time is going to be considered earliest start time for the succeeding activity. So D is the successor of A. So whatever earliest finish time of A is there, the same amount of time is considered as the earliest start of the D activity. And earliest finish means what? 2 units of time plus 3 units of time. So earliest finish time for D is going to be 2 plus 3, 5. What does it mean? That we have initiated the activity. Now, beginning of the A activity is 0 time, completion of A activity is 2 time. Unless and until this A is going to be completed, we cannot proceed for the D. So D is getting completed with 2 days, right? Let's assume it is in terms of a days. So after 2 days, we are starting the D activity. So that is why the second day is the earliest start time, and D activity is consuming 3 number of days. So earliest finish time for the D is 5. 2 plus 3, 5. Next one is your D. After D, we have E. Now you can see here, the preceding activity is C. C is getting completed in 4 days. So after 4 days only, we can start the E activity. So earliest start time for the activity D is the 4th day, right? Similarly, 4 plus 5. After 5 days, the E activity is going to be completely finished. So we are saying it as E is getting earliest finish time as 9 days. 4 plus 5, it is 9 days. The next one is your F activity. Now here you can see after A, we can proceed for the F. So here earliest start time for the F is the 2 days, and earliest finish time is 2 plus 4, that is going to be 6 days. Am I clear with this? Now, any one of you just give me the time for this D. Next activity is D. What can be the earliest start time for the G? We have 2 times, earliest start and earliest finish. Now tell me what time is going to be the earliest start time for G? Tell me.
Ma'am.
5.
5? Okay. Next, anyone else?
Ma'am, 9 रहेगा ना, like E का, because 9 is the, because 5 and 6 ideal हो जाएंगे, और 9 still like the job at C will still be क्या बोलते हैं, चक्कर चल रहा रहेगा ना, तो जो जिसका लेटेस्ट या लास्ट रहेगा नोड्स में उनका लेते हैं ना.
Yes, of course, right? So here in forward pass, can you say this? Maximum of 5, 6 or 9 we need to take. What I told you, unless and until your previous activity is not going to be completed, you cannot start the succeeding activity. So here for G, we are having 3 activities as their previous activity, that is D, B and E. Now D is getting completed in 5 days, B is getting completed in 6 days, and E is getting completed in 9 days. So unless and until all these 3 activities are getting completed, we cannot start with G, right? So we need to take the maximum time of whatever previous activity we are having as their uh, earliest start time of the G, right? So here we are just logically think upon it. As I told you that we cannot start G unless and until D, B and E is getting completed. So maximum time of either of this, whatever is having, that is going to be your earliest start time for the activity D. So earliest finish time is what? That is going to be your 9 plus 2 as 11. So your whole project is getting completed in the how many days again? Now, why this type of thing, when this type of things or questions are going to be arise, when there will be a merging activity. Whenever there will be a merging activity, at that time you need to take the maximum. Merge होना मतलब एक दूसरे के साथ कहीं पे connect होना, right? So G activity, G is the merging event for D, B and E, right? So whenever this merging is going to happen, at that time you need to take the maximum for the forward pass. Here also AND activity is merging of F and G. So which is having the maximum time? That is the G. So unless and until G is getting completed, we cannot reach to the end of the project. Am I clear to everyone? Please respond.
Yes, ma'am.
Yes,
Yes?
ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So this is the forward pass. Now, similarly, we need to focus on the backward pass. Here in the forward pass, we went from the left to right, right? Now in the backward pass, we will be moving from the right to left. So here we are having earliest time for the end activity is 11, and as it is an end, so it is going to be considered as the earliest finish time. So remember one thing, that start and end both are having earliest start and earliest finish as the same number of days, right? So let's move ahead then. Now let's go with the backward pass. So here we have to consider this 11 as the same, that is your. Now in the forward pass we have received the earliest start and earliest finish, right? But in backward pass we will be getting latest start and latest finish time. So at the end activity, we are going to consider this earliest start and earliest finish as the latest start and latest finish. So here we have taken this one. The first cell is going to give you the start and the second cell is going to give you the finish. So here in green, the very first is going to give you the latest start time and the second one is going to give you the latest finish time, right? So now let's move ahead then. Okay, so here whatever is the earliest start time, this is going to be the earliest finish time for the previous activity. So here in end, we are having earliest start time as 11. So here we have G. For G, we have latest finish time as 11 and 11 minus 2. So we are having 9. For G, or latest finish time, latest start time is 9. नेक्स्ट लेट्स कंसिडर दी एफ. हाँ बोलो.
जो फॉरवर्ड पास में वहाँ पे हम ऐड करते करते आगे जाते हैं और बैकवर्ड
यहाँ पे
में
माइनस करना है. यस
तो
यस.
इतना ध्यान में है, ये सोच के किया तो चलेगा ना. ये अर्लीस्ट स्टार्ट टाइम कौन सा है ये लिखने की जरूरत नहीं है ना, क्योंकि वो
नो
शब्द
नो
से
नो
कंफ्यूजन बढ़ सकता है.
नहीं नहीं. whenever see after practice directly you can go ahead with the earliest start and latest finish. Only these two times are very much important.
हाँ, नहीं मतलब
Earliest.
नाम मेंशन करने की जरूरत नहीं.
नहीं नहीं नहीं. There is no need. No, not at all. No need. No need to mention the time over there. This is for, see, ultimately your marks belonging to your methodology and your outcome. That is your result or answer. So if methodology is correct, your method is correct, then definitely you will be getting the correct answer. So full marks for your methods and the answer. Okay. Okay, so let's move ahead with this. So latest finish time for F is 11 and 11 minus 4, that is the latest start time is the 7 over here. Now you can see, now at the end I'm going to show you that what is the difference between this latest start time and the earliest start time. Okay, now right now you just understand the concept. Okay, next one is the D and B. So here we have for D the latest time of the G, the latest start time of G is 9. So the 9 is going to be considered as the latest finish time for D, B and E, right? Okay, now we need to go for the latest start time. So if you can see over here, 9 minus 5, latest start time for E is 4. For B, it is 9 minus 6, 3. Then for D, 9 minus 3, again it is going to be 6. Now, the decision point, that is for the, when we reach to the A. Okay, so now let's talk about C. So for C, we are having the latest finish time as 4 because E is having latest start time as 4, right? Now 4 minus 4, we are having latest start time for C is 0, right? Okay. Okay. Now the decision point is A. As I told you, in the forward pass, merging is very important. right? In the similar way, at the time of merging in the forward pass, you need to take the maximum one, but in the backward pass, you need to focus on the bursting event. This is called as a burst. जहां से एक से ज्यादा एरोज निकलते हैं ना, उस इवेंट को हम बोलते हैं burst event. So A is a burst event. It is having bursting event as F and D. So now when we are moving towards the backward pass, at that time we need to consider the minimum latest time of the succeeding event or activity. So here for F we have 7 as the earliest, latest start time for F, and latest start time for D is 6. So out of the 7 and 6, we need to take the minimum one. So here for A, we are having the latest finish time as 6. Similarly, latest start time is 6 minus 2 as 4. Right? Now, again for the start activity, it is a bursting event because from the start node, we are having activity A, B, and C. So now we have latest start time for A is 4, latest start time for B is 3, and latest start time for C is 0. So which one we are going to consider?
Zero.
0. Yeah, so minimum of 0, 3, and 4 we need to consider. So here we are going to take 0 as the latest finish time of start. And as I told you, the start and end event are having both latest and start as the same time. So here we are having 0, 0 as the latest start and latest finish of the start. Now, in the next one, अभी तुम्हें मिलेगा दोनों भी, forward pass and backward pass ka summary. You can see now. Okay. Now, on the basis of these, the I can say the path which is having both the earliest and latest time similar is called as the critical path. Again, I am repeating. The path of the project for which whatever events or activities are there, if it is having latest and start time both same, then that path is called as the critical path. So you can see over here for A, the earliest start is 0, earliest finish is 2. But the latest start is 4 and latest finish is 6. So both are not same, right? Similarly for the B, D, and F. But you can see over here for C, we are having earliest start and latest start as 0, earliest finish and latest finish as 4. So this is the same one. Similarly for E, we are having earliest start and latest start as 4, and earliest finish and latest finish as 9. So these are both same. Similarly for G, we are having 9, 11, 9, 11, right? So this path, that is start, C, E, G, end, this is called as the critical path. Am I clear? So now this is the summary for you. In this way I have mentioned.
मैम
हाँ,
so अभी like question ऐसे like किस पे आएगा, like find the critical path for this node है क्या, ऐसा node ऐसा आएगा?
no, that particular numerical I am going to discuss with you. This is the basics which I have discussed till now. These are not the, I can say, completion of the whole numerical. This is one part, right? Okay. So they are going to ask you in this way. They are going to provide you the data, right? And then the very first they are going to ask you that find out the critical path. So uh, for finding out the critical path, you need to draw the network diagram, right? So वहाँ पे आपको ये नहीं पूछेंगे draw the network diagram. Directly they are going to ask you the find out the critical path. So it means that indirectly they are asking you to draw the network diagram and then after find out the critical path. So that is the first question, right? In second question, they will ask for the floats and rest of the things. So here, let's go ahead with the critical path. In the red arrow, I have mentioned as critical path, but theoretical for you, the critical path is shown in terms of a double line arrow, right? So you need to, here I have mentioned a single arrow, but you need to draw the double line and then after an arrow. So double line arrow is an indication of the critical path. Remaining path are with the single line arrow. Am I clear? So whenever you in the examination, this question is going to be asked. So at that time, you need to draw the critical path in terms of a double line arrow. Otherwise, network diagram के marks आपको नहीं मिलेंगे. Am I clear? Am I audible?
Yes, ma'am.
Yes, ma'am.
Okay. So here we have, I have mentioned this days, and then after found out the critical path. So now, it may be asked, the numerical can be in this way. First, the data will be given to you and they are going to ask you then, first find out the critical path. So that is having 2 marks. Either 2 or 3 marks will be given to the network diagram. Then 2 marks will be given to your critical path, which you have found out. Then again, 2 marks will be for the slack calculation. They can ask you in this way, that find out the slacks of this particular project, right? So slack kya hai, float kya hai, that I have already mentioned in my previous slide, which I have shared with you. So here, these are the activities given to you. Now, whatever for activity A, suppose whatever time we are having, that is earliest start time and earliest finish time, then latest start time and latest finish time. So whatever we have calculated previously in the diagram, the same thing you need to depict in terms of a table. So the similar, these numbers are just from the figure, that particular network diagram I have projected over here in the table form. Am I clear? Now, the activity which is having this, as I told you, the earliest start and latest start time equal, these are called, for which we are having the slack as 0. So that is called as the critical activity. Now, how to find out the slack? That is start time, earliest start time minus latest start time, and either or otherwise earliest finish time minus latest finish time. So this is going to give you a slack over here. Okay, so for critical activity, we don't find any kind of a slack. Now, what do you mean by slack actually? Slack का मतलब ये होता है कि that many number of days you will be having, free time. Take an example in the previous slide I'm telling you over here. See, for the activity A, we have earliest start time as 0 and latest start time as 4. So here it means that if you wish to delay this activity A for 4 days, then it will be okay for you. You will not be having any kind of a delay for the whole project if you're going to make a delay of activity A for 4 days. Am I clear with this? Am I audible?
Yes, ma'am. फिर से एक बार
Yes,
बताना.
ma'am.
फिर से एक बार बताते हो. लेकिन आपको स्लाइड दिख रहा है क्या? दिस वन क्रिटिकल पाथ वाला स्क्वायर
Yes,
स्क्वायर के
ma'am.
साथ.
दिख रहा है.
हाँ.
हाँ.
Now consider over. Let's talk about activity number D. Right now, activity D के लिए earliest start time is 2 and latest start time is 6. Right? Am I clear with this? So it means that activity D, early to early you can start in 2 days, or otherwise you can also start this activity D on the 6th day.
Okay.
So latest start time of activity D is the 6th day. Again, for activity F, earliest start time is 2 and latest start time is 7. It means that activity F can be early to early start in the 2nd day, or otherwise you can also start this activity F on the 7th day, right? If you are starting on 8th day, then definitely the whole project is going to be delayed. But if you are starting it on 7th day, then also there won't be any effect on the completion of the project. But here, if you can see activity C, E, and G, Earliest start and latest start time are same. So if you are not going to start your activity E on 4th day, the whole project is going to be getting delayed. The whole activity is getting delayed. So it means that your project is going to be getting delayed. Am I clear with this now?
Yes, ma'am.
Okay. Okay. So here the slack is actually basically calculated for all the activities, so that we, if suppose some of the resources are going to be shared with the other site, right? If the same company is having 2, 3 sites, so we cannot buy a huge crane for every site. That crane itself is costing in terms of a lakhs of rupees, right? So we cannot purchase for each site the individual cranes. So from this slack activity finding out, we can now share these resources. So unless and until this first activity or on first site is going to be completed, we can delay some of the activity with respect to crane to the next site or next location. Am I clear with this? So some of the, if you are if you are going to work in the company now, so if you belongs to the project department, then simultaneously you need to work on the 3, 4 project. So at that time this slack time is going to be utilized by you कि चलो एक साइट पे ये एक्टिविटी ये खत्म हो गया, now I can go to the next site because the same activity is going to be delayed और इसका latest start time delay है 4 या 5 days, right? So you can manage simultaneously 4 to 5 projects, depends upon the slacks. So basic meaning of finding the slack is to share the resources. You are, if you are working under the project department, then you are the resource for that particular company, right? So now this resource is going to be shared by various projects. Am I clear with you?
Yes, ma'am.
Yes, ma'am.
मतलब मैम
मैम फ्लोट और
critical
स्लैक में क्या डिफरेंस है?
क्या होता है ये जो स्लैक होता है ना, दैट वी आर मेकिंग यूज ऑफ इन दी CPM, and floats are going to be, both are having the same meaning, but the application is different. CPM, critical path method, is used for the projects which are having a tentative time calculation. Take an example, if I want to construct a building, then I know that this many resources are going to be required, and by this many days I'm going to complete this particular construction of the building, right? So here we can implement the CPM method because we know tentatively that this particular activity is going to consume this many days, because previously we had an experience with the other building. But if I'm going to innovate something, take an example in the COVID, invention of the COVID vaccination, do we know? Because previously COVID doesn't exist, so we don't know how many days and how much time it is going to require to invent this particular activity. So when the these activities don't have a foundation or previous experience for the time, so at that time we are going to implement the PERT method to find out the uh, this float or slack. Am I clear with you? So whenever there will be an R&D activity, so at that time we don't have any judgment that how much time it is going to take. So at that time we are implementing the PERT, and whatever time we are going to find out, that is called as a float time over there in that particular project, right? So
Yes, ma'am.
whenever, yeah, when we are going to take the PERT examples, at that time I'll make this very clear. So am I clear for this CPM now?
Yes,
Should
ma'am.
I jump to the next one?
यस मैम, मैं क्या
Okay.
बोलता हूँ, ये जो स्लैक टाइम है ये
Hmm.
डिजायरेबल है कि नहीं?
Sorry?
ये जो स्लैक टाइम हमें मिलता है, बफर टाइम मिलता है, ये डिजायरेबल है या डिजायरेबल नहीं है?
Actually, when we are sharing the resources, so at that time, it is very good for you to have a slack time. You cannot delay the activities which are falling on the critical path.
हाँ, हम तो क्रिटिकल पाथ पे ही चलना पसंद करेंगे ना, तो वहाँ पे तो हमें स्लैक टाइम नहीं मिलेगा.
No, for the critical path, we don't have a slack time. So there we cannot share the resources.
अच्छा, और यूजुअली हम क्रिटिकल पाथ से ही जाना पसंद करेंगे ना.
No, every activity you need to complete.
Okay,
You
okay,
didn't
okay.
get the meaning. See, when you want to complete the whole project, तो उस टाइम पे हम सपोज कंस्ट्रक्शन का है तो उसमें ये नहीं बोल सकते कि मैं सिर्फ फाउंडेशन बना दूंगा या और साइड बाई का पिलर्स बना दूंगा. इन बिटवीन आई एम नॉट गोइंग टू कंस्ट्रक्ट द वॉल, है ना. वॉल कैन बी कंस्ट्रक्टेड एनी टाइम इफ यू हैव अ फ्रेम, इफ यू हैव अ पिलर्स, if you have a structure, you can
मतलब
feel it
पूरा,
anytime.
हाँ मतलब पूरा नेटवर्क डायग्राम कैसे भी करके पूरा करना ही है. जहाँ पे
हाँ
वो सिर्फ
yes.
क्रिटिकल पाथ है ऐसा. ओके.
So whatever project is given, each and every activity you need to complete, otherwise the project is not going to be declared as complete. Take an example, you have constructed a building. So if you are planning कि नहीं अभी सबसे पहले तो मैं कलर लगाऊंगा, अरे फाउंडेशन नहीं हुआ, बिल्डिंग नहीं हुआ, तुम कलर कैसे लगाओगे, है ना. समझे. तो कलर का तुम डिले कर सकते हो, बट दैट एक्टिविटी हैज टू बी कंप्लीटेड. समझ में आया. हाँ, जैसे इलेक्ट्रिकल वायरिंग्स एंड एवरीथिंग कैन बी डन लेटर ऑन एनी टाइम, बट वी कैनॉट. हाँ, हम जब तक स्लैब को तुम डिले नहीं कर सकते हो. हम सोचेंगे कि नहीं पहले इलेक्ट्रिकल करते हैं, अरे जब तक स्लैब नहीं होगा, कंस्ट्रक्शन नहीं होगा बिल्डिंग का, तब तक हम इलेक्ट्रिकल थिंग कहाँ से लगाएंगे. Getting my point? So all the activity you need to complete in the project, but you have a flexibility for the sum of the activity that you can delay it, but you cannot completely eliminate it. Getting my point?
Yes.
समझ में आया ना. मतलब हर एक्टिविटी आपको कंप्लीट करनी ही है by any how. Okay?
Yes.
Okay, chalo. So this example I have mentioned in the slide. Activity and durations I have given to you. I'm not going in detail because I want to complete today the part as well, so that in the next lecture I can start with the line balancing. ठीक है, हम ट्राई करेंगे इसको आज कंप्लीट करने के लिए. So here now previously we have taken activity on node, but many of the students are convenient with activity on arrows. So ये हम कैसे करेंगे, that I am explaining. So data has been given to you. Now here we are going to construct the network diagram. So as I told you that we are drawing this network diagram on the basis of activity on arrows. So here we are taking activity on the arrows, right? So here we have the nodes and we are going to consider these as the different activities. So when we are taking this activity on arrow, so at that time we are mentioning it 1 to 2, 1 to 4, 1 to 7 in this way. Okay. So here I am constructing this network diagram. If you can see it, 2 to 3, that is 4. Now we have 3 to 6. So here we have 3 to 6 activity. So here we are mentioning this time duration on the arrow, right? Okay. Previously on activity on node, we have considered this time duration in the node, on the node itself. Okay. A little bit faster I'm doing this network diagram so that I can explain you. The video of the slides I have already mentioned or given you the link. Okay, now see here. Instead of early start time, early finish time, latest start time, latest finish time, I'm more interested in this one. So I've considered in this way, right? As I told you, I'm more having an interest in earliest start and latest finish. So here we both have. Clear? Because earliest finish time, we can add earliest start time with the duration, we can have this earliest finish time. Similarly, latest start time, we can find out by, deducting the duration from the earliest finish time. So if you can construct now, as I told you, after practice, you'll be getting this. Okay? So directly you find out the LST and LFT. And on the basis of these two, by plus and minus duration, you can have your EFT and LFT in this way. Okay. So here free float, total float वगैरह क्या है उसका आगे मैंने diagram दिया हुआ है. So sometimes it happens that when this float and slack are, these words are going to be used as interchange of with each other. So sometimes we are making use of the float word, sometimes we are making use of the slack word. But the slack word is a very general, it is terminology, but the float is having different category, like total float, free float, independent float. अगर आपको याद होगा तो मैंने लास्ट उसमें I have the here in this slide I have mentioned what is float, right? And slack is a very general terminology for the deduction or addition of the EST, LST, EFT and LFT. Okay, just go through this slide, you'll be getting the picture clear. Okay, so I was here in this slide. Go to the next slide. Okay, so this is my network diagram and critical path C. I have drawn it over here as a double line arrow. Can you see this? Any one of you respond?
Yes, ma'am.
Yes, ma'am.
So in this way, you are supposed to mention in your diagram. Okay? Take it. Yeah. So here LST in the same way we have mentioned, and this different types of float I have calculated over here. So आप थोड़ा सा ये just go through that my equations which I have mentioned in the previous slide, and you'll be having this floats. Okay. And for the explanations, I mentioned here the equation as well. So just calculate that. Just try to practice this particular numerical specifically. Okay. एक करो try, फिर दूसरे सारी activities के लिए you'll be definitely having the practice. Okay. Now let's go ahead with the thought. Now here three different types of time we are going to consider: the optimistic time, the pessimistic time, and the most likely time, and the expected time. See, optimistic means what? Some people are making use of the word, you are very optimistic. Means what?
Positive towards everything.
Yes, very good. So here we are considering that the minimum possible time required to accomplish an activity or a path, that is your optimistic time. Means everything is normal, everything is in favor of us. ठीक है, सब कुछ आपको रेडीमेड मिल रहा है और आपको एक्टिविटी कंप्लीट करनी है, दैट इज अ ऑप्टिमिस्टिक टाइम. बट इट इज नॉट एवरी टाइम पॉसिबल. Sometimes we need to struggle with the natural calamities. Take an example. So at that time we have to calculate the pessimistic time. So this is the maximum possible time required to accomplish an activity, right? जब सब कुछ आपके फेवर में नहीं है तो आप कितने टाइम में कंप्लीट करेंगे? And most likely time and expected time that I'm explaining. Most likely time means normally most of the time this activity has been completed. We are interested in the expected time. So here expected time is given this particular symbol STE. TO is optimistic time, 4 times of T most likely time, plus pessimistic time whole divided by 6 is going to give you the expected time. So now this PERT example is been through this TE we are converting it into the CPM. So उसका शुरुआत का जो स्टेप रहेगा that is your only to find this particular TE. TO, TM and TP is going to be given to you and you need to find out the TE. Directly let's go to the numerical. Okay, so here activities has been given to you, optimistic time, pessimistic time, and most likely time is given to you. So the whole project is given in terms of a part. Now for the to solve this particular numerical, we need to first convert it in terms of a CPM. So to convert this in terms of a CPM, we need to find out the common time or an approximate time by which the activity is getting completed. So we are converting these all the three times into single time, that is called as the TE. See here, second last column. So after implementing that equation, all the activities has been, we are expecting that by this time it is going to getting completed with. Okay. And then after we are having some kind of a standard deviation formula. So as we know, sigma square is equal to TP minus TO divided by 6 whole square. So that I have mentioned over here in this last column. Okay. So now for the every particular this part, we need to find out the this TE. For each and every activity, find out TE. On the basis of TE, we need to draw the network diagram. Now you have a single time with you, right? That is a TE. So find out TE, then after you will be able to draw this particular network diagram. After network diagram, find out the critical path which is consuming the maximum number of days. So here you have 1, 4 and 7 as your critical path. So the whole project is getting completed with the 25 days. Just remember one thing, critical path is the path which is consuming the maximum days. If beyond these days, that is for particular this numerical, we have a critical path as the 25 days, right? So if you are going to consume one more day, then you need to incur some cost, and which is ultimately a loss to the project. So as far as possible, find up your project within the critical path days. Okay. Okay. So here we have a critical path, as well as we are having this variance also. Now we need to calculate the standard deviations, that is 5.656, and expected project duration is this much. So next thing it is going to be asked that if what is the probability that in the 27 days you are going to complete your project. So just implement the this formula which I have mentioned in the earlier slide. Just put the values, substitute the values, and you'll be getting this 0.35 over here. So from this normal distributions, as we have mentioned in the earlier slide, the start of this Z and probability. So if per type of question is going to be asked and the probability is going to be asked, at the time, the standard normal probability chart will be provided to you. So don't worry about it. So now 0.35, what is the 0.35? So here we have 0.3. Are you able to see the arrow? So 0.35, so till 0.05 you need to go. So we have 63.68% probability to get complete this particular. Okay. Just try it once. Please try this particular numerical, understand it thoroughly. And then also if you have a question, बोल.
Can you explain it one more time? थोड़ा पोर्ट में confusion आ रहा है अभी.
इसमें
पूरा लाइक ये दिस ये स्लाइड मैम लाइक द एक्टिविटी ऑप्टिमिस्टिक एंड ये पीपीएन
see the time activity will be given to you, optimistic time will be given to you, pessimistic time will be given to you, most likely time will be given to you. So first 4 column will be given to you. Now you need to find out TE, right? So that is the expected time to complete. So for this, we are having an equation over here, which I have mentioned in the earlier slide. That is TE is equal to TO plus 4TM plus TP, whole divided by 6. Right? So
yes,
implementing, so for activity 1 to 2, what will be the TE? TO, that is 3, plus TP 15, plus 4 times this TM, that is 4 into 6. Now summation karo divided by 6, so you will be getting 7. Just now calculate, any one of you. Any one of you just calculate this. 6 into 4, just do one thing. 6 into
Yes,
4
ma'am.
is equal to whatever you are having plus 15. 6 into 4 matlab 24 plus 15 plus 3. How much you have received?
7.
Huh?
7.
So you have received this 7, na, T? So in similar way, the very first step is to find out this T for all the activities. Okay. Next thing is, remember this equation. Sigma square is equal to, this is the standard deviation. Sigma square is equal to TP minus TO. What is TP? This one. TP will always be greater than TO. Right? So TP minus TO divided by 6 और उसका पूरा होल स्क्वायर करो. टेक एन एग्जांपल ओवर हियर. अगर हम देखें इसमें, चलो 1 2 3 TP minus TO, right? How much it is? 12.
12.
Yeah. So 12 divided by 6, how much?
2.
2 का स्क्वायर कितना हुआ? 4. So here you can
4.
see your sigma square is 4. Standard deviations. ठीक है? Okay. Now ये standard deviations मिलने के बाद you need to find out this. Now you have TE ना? TE देखो 7, 6, 14, 5 सब मिला हुआ है. So उसके 7, 6, 14, 5 सब यहाँ पे mention किया हुआ है. तो वो सारी एक्टिविटीज के लिए फर्स्ट ऑफ ऑल यू नीड टू प्रिपेयर दिस नेटवर्क डायग्राम. ठीक है. सो सेकेंड स्टेप इज टू ड्रॉ द नेटवर्क डायग्राम ऑन द बेसिस ऑफ टीई. जैसे सीपीएम में किया था, इन द सेम वे यू नीड टू ड्रॉ द नेटवर्क डायग्राम. ओके, एम आई क्लियर? आयुष?
Yes, miss.
ठीक है, चलिए नेक्स्ट. देन critical path you have found out. How many days it has been given over here? Now in the numerical, do you have your this PDF of my slide with you? No.
Yes, ma'am.
That is ठीक है. So what the very first question is, what is the project duration? So your project duration is your nothing but your critical path. So that is your 25 days. Now next it has been asked, what is the probability that the project will be completed in 27 days? So theoretically you need to complete this project in 25 days. But some, as this is a PERT, so you can see in the CPM it is very firm that you need to complete this activity. But as I told you, this is PERT and we are implementing it in R&D activity. So we never know what exactly time is going to be required to complete this project. So here we have in our mind theoretically 25 days. But in the question it has been asked that what is the probability that you will be completing it in 27 days, 2 more days, right? So here critical path, so A वाला आंसर आपको मिल गया. Now the next one के लिए you need to first find out the variance. Now variance आपको किसके लिए find out करना है? For the critical path की जो भी activity है वो. So what are the critical path, what are the critical activities? So this is 1 to 4 and 4 to 7 are the critical activities for us on this project. ठीक है. So 1 to 4 का sigma square कितना है? 16, right? And 4 to 7 का sigma square कितना है? It is 16. So you need to make a summation of both these. That is 16 plus 16. Right? So here the sum of variance along the critical path is your 32. 16 plus 16, 32. Next step is now find out the standard deviation. So we have sigma square as 32. So uska आप root लोगे तो you will be getting, this is your sigma square ना. So now you need to go for the standard deviation. So under root of sigma square, so you'll be getting 5.656, right? T आपको पता है एक्सपेक्टेड टाइम है 25 डेज में कंप्लीट होने वाला है. आपके पास अभी सिग्मा है. सो नाउ इंप्लीमेंट दिस इक्वेशन. z इज इक्वल टू डी माइनस टी अपॉन सिग्मा. नाउ टी आपको पता है 25 है, सिग्मा आपको पता है 5.65 है, d इज बिन गिवन That is, in how many days this in 20 days, what is the probability that in 20 days this project is going to be getting completed? So D is given as 27. So when you implement these, substitute these values, you will be getting Z is equal to 0.35, right? Okay, so now from this 0.35, go to the table and find out what is the value. So it is positive. We have derived this Z in terms of a positive value. So now if you can see over here in this chart, Z ka value 0, 0, 0 0.1, 0 0.2, 0 0.3. Can you see my arrow? हाँ, दिखाई दे रहा है क्या arrow?
Yes, ma'am.
Yes, ma'am.
Yeah, in 0.3, just move towards the 0.05. So here you will be getting 0.35 का वैल्यू आपको कितना मिलेगा? 0.6368. Multiply it by the 100. So you will be getting 63.68 as the probability of getting your project completed in 27 days. समझ में आया सबको?
इसी में आप वो लास्ट पार्ट वापस एक्सप्लेन कर सकते हैं प्रोबेबिलिटी वाला.
This probability wala. Now till calculation of Z, it is clear?
Yes, ma'am.
Okay, now Z का वैल्यू कितना आया? 0.35. Okay, so now go to the Z table. ये Z का टेबल है, दिख रहा है आपको? Now you can
Yes,
see
ma'am.
over here the Z value दिख रहा है आपको?
Yes, ma'am.
Unmute yourself. Now keep your mic unmute. Okay, so Z is equal to आपका वैल्यू कितना आया? 0.35 ना? तो now Z का 0.3 कितना है? इतना है. 0.3 over here. Can you see the arrow cursor?
Yes, ma'am.
Okay, now move towards the right hand side, because right hand side you have 0.00, 0.01, 0.02, 0.03, 0.04, 0.05. Now you might have learned in the mathematics that how to find out, how to read this standard normal table. तो यहाँ पे देखो 0.35 के लिए कितना आएगा? If you move your cursor towards 0.05 on the row of 0.3, you will be getting over here 60.6368. Do you get this value?
Yes, ma'am.
Okay, now this your probability for Z equal to 0.35 is 0.6368, right? So now come
Yes,
to
ma'am.
this slide. Okay, now 0.6368 का मतलब क्या हुआ? Multiply this by 100. So you will be getting your probability in terms of a percentage. Okay.
Okay, ma'am. Yes, ma'am.
So your probability of getting your project completed in 27 days is 63.68%. Am I clear?
Yes, ma'am.
Okay, ठीक है. तो ये सारे न्यूमेरिकल्स का आप लोग प्रैक्टिस करो, and then next lecture whenever I'm going to conduct it, so at that time if you have a query, please raise it. But practice this per PERT and CPM today itself. From the book of Telsung, or otherwise I have given you the PDF as well. For the from the various book, I have collected the scheduling numerical, and then I have posted it in the group. So just go through it. Various types of numericals are available. So from there you can practice. Okay.
Okay, ma'am.
ठीक है.